So we're going to talk about what's meant by vector addition. So let's say we have a vector A and a vector B, and we want to calculate the vector sum, A plus B, which will be a new vector. So we arrange it in a tip-to-tail arrangement. So this is the tail end of A, and this is the tip of A, and this is the tail end of B, and this is the tip of B. And then for A plus B, this is the tail end of the new vector A plus B, and this is the tip end of the vector A plus B. So it's important to arrange the two that we're adding up correctly. So let's say we're going to figure out A first, B second. Okay, of course, B plus A will give you the same vector. Your drawing will just look a little different. So if we wanted A plus B, we're going to start tail, tip of A in our drawing. And then we're going to take the vector B and we're going to position it starting at the tail, tip arrangement for B, where they're touching right here at the tip of A and the tail of B. All right, so then we're going to draw in A plus B, which starts at the tail of A and ends at the tip of B. This is the resultant vector A plus B. So this is the way that we would draw a vector diagram indicating the addition of vector A and vector B. So here we're going to take two vectors, vector U and vector V, and we're going to perform several operations using those two vectors. So first, I'm going to look at the components of vector U. So I'll put it up here. So U is 1 in the X, comma, 1 in the Y, and then V is 1 in the X, 2 in the Y. So first we'll calculate the vector U plus V. So that means I'm going to tip to tail arrange U and V. So U is already okay where it is. Now V, we're going to go starting at the tail. We're going to go 1, 2 for V, so that V is arranged like I showed you in the prior slide. Now I can draw in the vector U plus V starting at the tail of U like that. Alright, so now I can see the X component of the new vector is 2 and the Y component is 3. So that's the vector sum, the new vector U plus V. Now the next one says what is 2 times the vector U. So that's just going to increase the length of the vector U by a factor of 2. So it'll go out to here now. So I can see that it's going to be 2 in the X and 2 in the Y. Alright. Okay, the next thing we're going to do is 4U subtract 2 times V. So when we have a subtract, we just change the signs of V and then add 4 times U plus the new V, which has been reversed in the other direction. So that's negative V. Alright, so now if I go ahead and figure out what negative 2V is at the same time here, that'll make things a little easier. So I'm going to double 1 and double 2. So this one right here is the one I'm going to add to 4U. Alright. Alright, so let me just move that over here so I have enough room to draw 4U on the diagram here. So let's draw 4U first. So it's going to go 4 times the U vectors will be all the way out to there. So that's the vector 4U. And then we have to add on to it the vector negative 2, negative 4. So that means I'm going to go from here, from the tip end of 4U, negative 2 and negative 4. So it's going to wind up down here. So 1, 2, 3, 4. It's going to wind up right here. So drawing it in, it ends up right there. So now my vector sum has to start at the tail end of the first vector and wind up at the tip end of the second vector. So that green one is what I'm looking for here. So that's 2, 0. Alright, so let's talk about negative v. So that's essentially negative 1 times the vector 1, 2. Okay, so it's just changing it to negative 1, negative 2. So if I draw it on there, it's just going to be down here at negative 1, negative 2. So the last one here I'm going to do in two different ways. I'm going to set up the math and then do the vector addition diagram. So if I'm looking at v minus 3u, I'm going to take the vector v. So the vector v was 1, 2. I'm going to subtract 3 times the vector u, which was 1, 1. And I'm going to get a new vector, which is called v minus 3u. So I could say 1 minus 3 times 1 is negative 2. And then 2 minus 3 times 1 is 2 minus 3, which is negative 1. So I did it sort of like a mathematical equation. Now let's go ahead and draw what it would look like tip to tail. So I already have the vector v on my diagram. So here's the tip of v. Here's the tail of v. So I have to start right here at the arrowhead and draw on the vector negative 3, negative 3. So that means I'm going to go, so I went 1, 2, 3 in the negative, 1, 2, 3 in the negative, and I ended up right there. So I'm going to draw in negative 3u, and I wind up at that point. So now my resultant vector v minus 3u has to start at the tail end of v and end at the tip end of negative 3u. So if I look at how that compares with the one I did mathematically, I can see I've gone negative 2 in the x, which matches this, and negative 1 in the y, which matches this. So this is the diagram of what we did mathematically. Okay, so that's how we draw and configure vector scalar multiplication, which looks like this, multiplying by a constant, and vector addition or subtraction, which is basically the same operation, which looks like this, and in the tip to tail configuration on the diagram.